Okay, we talk through level 2. Number 1, given that y equals that, find dy by dx, straightforward enough. And find the x coordinates where the gradient is 4. So just dy by dx equals 4 and just work it out your normal way. As we look for the x coordinates. Number 2, show that the point 1, 2 lies on both curves. So you sub that point 1, 2 into both curves. Just check it works out. Part 2, show the curves have the same gradient at this point. So you do dy by dx for each of those curves. And then you sub in 1. And then it says, what do these tell you about the two curves? So I think the gradient's at the same point. So it means they must meet there. Number 3, the displacement is given by s. So s equals this. Find the velocity. So you're differentiating s with respect to t. So it's the same principles, but instead of y's, you've got s's, and instead of x's, you've got t's. So you just differentiate that, ds by dt, just your normal way. All written out for you. And then it says find when it is stationary. That's when it's not moving, the turning point. So the gradient is 0. And actually that's all in the notes for you there. Number 4, multiply out your brackets and differentiate for each of those. And again, that is all under the answers there, which are posted for you. Question 5. A curve has got, let me get this in here. A curve has got this equation, ax3 plus bx, where a and b are constants. And at the point where x is 1, y is 8. So that's the first thing I did there. So when x is 1, y is 8, just sub it in. You've got the equation. You're told the gradient is 12. So the gradient is when you differentiate dy by dx. It's just your normal way. So you're told when x is 1, the gradient is 12. So just subbing that in, you get two equations, simultaneous equations, and then you're able to find a and b. Now, over to number 6. Show that the tangent to the curve. So the first thing I would do there, I can get it up. So write out the curve, you want the tangent. There's your formula for the tangent. Now, just checking, it says the x coordinate is 1. So when x is 1, find the y, put it in. Work out your gradient, dy by dx, x is 1, so you've got your gradient. So you've worked out your equation of the tangent, just your normal way. So it says, show that it passes through the origin. So to show, there's your tangent. To show it passes through the origin, sub in 0, 0. Number 6. So find the equation of the normal. Given that the normal cuts the x-axis, find the equation of the normal, I have not done yet. Equation of the normal, y minus y1 equals minus 1 over m, x minus x1. You're told the point and you know the gradient. So just sub your information in and you get this equation. Then the question asks you for the normal cuts the x-axis at q. So it cuts the x-axis when y is 0. So put 0 in there. So you get x equals 17, that's your point q. Then the question asks you for the area of OPQ. So I would draw out a wee diagram. You see a triangle, area is base times height divided by 2. That one's quite complicated. We want that one. Number 7. We've got here the graph y equals there. Find the equation of the tangent. So write out your equation of the tangent formula. X is p. So use the normal. When x is p, work out y. Whole lot of p's there. So put your x in. So x and put your y in. You've got to work out the gradient. So I have it over the side. Just differentiate as normal and put x to be p. So your gradient is in there. And then what I've done is I have taken this minus through here, times out this bracket, tied it up to get y equals. So part 7, part 1. Find the equation of the tangent. Done. Part 2. Find the equation of the tangent when b is 0. So you put b to be 0 in there, and there's your new tangent. And part 3. Explain why the reference to the graph. So explain by reference to the graph why the answer to 2 is unchanged for all values of a if p is 0. So if you look down here, b equals 0 is the curve. So if you take the b out of it, b is you've not. You've just got ax squared plus c. So just normal x squared graph, lift up c. And when p is 0, the tangent is going to be a straight line. So the tangent is always going to be that flat line. So it's going through the y-axis at c. So the tangent is always going to be y equals c, so it doesn't depend on x. If you're not getting that, don't be too concerned about that. Number 8, show that the graphs cross. Whenever graphs cross each other, you put them equal, so they intersect, and solve out your equation. And we have one solution. So if you've got your x, remember to find your y to get the y coordinate. So you've shown where they cross. And part 2 of this, find the gradients of the two curves at P. So you've got your two curves written out, differentiate, and you know that x is 0, and each just work out what dy by dx is. And now you can see 1 is 2 and 1 is minus a half, so they're perpendicular. So they meet at right angles, are perpendicular. And part 4, the last bit, show for any value of a at the curve crosses the curve above a constant angle. That's a bit of a strange question. See I've written out there. Differentiate it, put in x be 0, so the gradient is minus a half, which doesn't depend on a, so it's always going to be constant.